Here is another update of Chapter 5, which will take me a bit because Section 5.3 is a very long read. Actually, this is going to be showing all the problems in Section 5.2 that I didn't do in the last update, so 11 to 24, and then most of the reading for Section 5.3, but not the whole reading. It just takes a while. It's a really long section. So actually, there's no reading update here, but there are 20 proofs and 24 problems, some with 2 proofs in this update. And so I am up to 497 attempted problems, and of which 314 are attempted proofs. And this is here as a prop mostly, but I'm going to show the material that I'm showing. This is actually what I think will be my commuting copy of this book. So in section 5.2, it's all about diagonalizability, and I showed the reading for this in the last update. And I also showed that I had done the first 10 problems, or attempted, I should say. And then here, I completed all of the other problems. I attempted all of the other problems. I got into a pretty good groove, so I'm very happy about it. However well I did the proofs, I did get to the point that by the time I got to these problems, to the direct sum problems, I felt like I was cruising. Then the Markov chains section, of which I'll make a video of selections from the other books that I have, as well as this one, showing how different books use the Markov chains application in their section. Yeah, in their books, how they do those sections. If they do, not many books of linear algebra do not cover Markov chains. So yeah, it's a very long read, all about summing these matrices, these transition matrices, where you always sum to 1 along the vertical. So for this example, if you sum the row, you're going to get 0.92, so it doesn't add up to 1. But if you add up along a column, you get 1 for every column. And there's various applications for stochastic systems or stochastic applications. There's a probability vector that is used. And so it really uses the diagonalizability for problems. And there are ways where you sum all the probabilities. So of course, if you multiply in a certain way this matrix, you will be adding these numbers to 1. And that's where you get this business of the eigenvalue being 1. Then it gets a little more complicated when you turn it into complex matrices, and you use the Gershgorian disk, which is on the complex plane. And that's what the latter part of the chapter is, and that's what I have been reading, all this. And now I think I need to finish from here on out. I'm up to here. Okay, so that's the book, and that was the update. Let's go to the actual work itself. So again, as I mentioned, I started doing the latter problems, problem 11, what I felt was an easy proof. 12, there was an answer, right? There is an answer for it. I worked at it pretty hard, but I did not really deliver completely. There were things that I got right, but then I didn't fully flesh it out. So yeah, I actually took the answer and then just went through it and reviewed it. Then I moved on to problem 13, which I think is okay of a proof, but I'm not sure. And then 14C, I think I did okay. 14B, it's not the best proof. 14A, I think, was easy. I found a really good example for, is this the case? Let me see. No, there's the example that I found on the web that explains something was later. Then 15, I got right. Yeah. Then 16, I think, was a good attempt, a solid attempt to the proof. 17 seemed like a very easy proof. Yeah, here's the example. So what happens when matrices are simultaneously diagonalizable? Well, they have the exact same Q matrix. So the Q matrix for these two matrices is the same. They have the same eigenvectors. And so the key thing is that they commute. So AB is equal to BA. And the book does not have an example. There was a very simple example out of Google. These days you can do a query and it looks like a ChatGPT result. That was wonderful. That really helped, because then that sealed the deal. It's the same Q. Got it. Then I moved on to proofs, and then I started really getting momentum for these latter proofs. They seem to be straightforward. Just crank them all out. And then, of course, the direct sum proofs were pretty straightforward. Yeah. And then I got onto the business of reading section 5.3. I haven't really done my little coloring business for all of it because I'm still in the middle of almost finished with the reading. Not in the middle, past the middle. But yeah, I just read all of most of section 5.3. And of course, as always, I try to solve the examples. And I started trying to solve one of the examples, and I went completely the wrong way. But then I said, I want to figure it out. And sure enough, I did get back. I used a different path to the matrix. I had done this column. Then I said, how about I try that row? Then I made fewer mistakes. No mistakes, actually. I made some mistakes here that just threw me off. The moment that I saw the characteristic polynomial with a 1448 right here, I knew I was in the wrong path. And then when I got here and I saw that I could easily get the eigenvalues, I was in business, as they say. And sure enough, I fully solved it. They're not asking you to fully solve it, but I like to do that. Then the whole city suburbs example, just reading it, nothing special. Then the community college example also. And there again, I actually worked it out. Yeah, so the book just gives you what the Q matrix is. I actually worked out the whole Q matrix and I got it right. Yeah, then some additional reading, summing the columns, summing the rows, and giving it a value, and then doing the whole thing about the eigenvalue being within a circle, the unit circle in the complex plane, but it does not include the outer boundary except for lambda equals 1. So it does not include lambda equals -1. It does not include lambda equals plus or minus I either. Yeah, and I'm just trying to finish up the reading for this very long section.